Well, yeah, I just want to speak briefly about the background of this web application that I developed. And the background is that for my PhD thesis, I worked with constructed technosoils that should be used for urban greening applications. So whenever there should be established a green space in a city, I argue that the soil, the lacking soil, because the soil is sealed, should not be replaced with natural soils, but with soils made from waste materials or excavated soils that we already got from the city. So I'm also very much in favor with the project that was suggested before with the carbon. The black carbon. Anyway, working on this topic, more and more I had to face the question, how much of this extra soil do we actually need? And I came up with the idea to answer this question based on GIS data, so map-based. And I wanted to see for my neighborhood to begin with, in Berlin, how much soil would be needed if we greened this neighborhood that I live in to a certain extent. And just to give you an idea of what it looks like, for example, this is the look out of my window. The upper picture shows the look out of my window last year, and maybe some of you still remember my video presentation. The part of the video presentation of Thomas and me that I held was in front of this tree. And back then, this was the parking lot. But since 2 weeks ago, this was turned into a tiny green space that we call Parklet. And the municipality actually supplied us this Parklet, this high raised bed, and brought us some soil in order to fill it up. And now we have, instead of a car, always a little green space in front of our house. But what now? Or how can we now answer the question if we extensively apply, or if not only this one parklet is going to be in my neighborhood, but several of them, we need to know how much soil we actually need to establish this. Or if we want to green the roofs, or if we want to increase the tree pits of the trees that are dying now in Berlin this year a lot, and last year also, there will always be a demand of soil arising from these measures. And I liked your remark, George, about Peter's poetic descriptions of increasing the surface area. And this is actually also one measure to increase the surface area. So the minimum surface area that we find right now is the sealed one. And if we want more of it, we have to establish some more soils. We need to get more soils into the city, but how much actually? And I'm going to let someone in. And now I'm going to show you the app that I developed that enables us to play around a bit with the idea of greening the city, and enables us to estimate how much soil this is going to need. So there's a really rich database, open database of GIS data for the city of Berlin. And the app that I created, it's based on this data. And this is where I live. This is the neighborhood called Wrangelkiez in the center of Berlin, in the district of Kreuzberg. And the city of Berlin, they conducted a street survey where they actually measured the extensions of all the surface ceiling of Berlin. And based on this data, I developed a map showing which kind of surface we have. So this is kind of an explorer map where you can hover with the mouse, and then you can see which part of the street is made from which material and what the purpose of use is, so the surface type. So I try to internationalize the app a bit, but the data behind it is still in German, so I'm going to translate on the fly. So the gray part, for example, is where the cars drive, the driving lane, and it's made from a certain kind of stone, cobblestone, an old kind. And the yellow greenish parts are the walkway, which are made from a smaller type of cobblestone, but it's constituted of different materials. Then we find some parking lots, for example, for 4 cars. The round circles are representing the trees, and you can hover over and get some more information on the species and the age, for example. This is a 38-year-old oak tree. I live in this building, and the parking lot that's now transformed that you saw is this one, for what used to be for 1 car, and now it's transformed into a parklet. So there's the opportunity to discover the neighborhood a bit and see what the materials are that we find. And then there's some opportunity to evaluate the data a bit and see which of the surface types cover how much of the total surface is in this diagram, also still in German. But I want to raise your attention to this diagram, which shows the amount of surface, or the surface types covering the public space, which is the space that the municipality can take care of. And here we see in my neighborhood, there's a lot of pedestrian, a lot of space for pedestrians, which is nice. So 1/3 of the public space is for pedestrians, the walkway. But then we have the driving lanes, and to a lesser extent, some green space, 2 different kinds of green spaces, and 2.4%, for example, of the public space is open tree pits and open, real open, uncovered urban soil. Then there's some playgrounds that you can discover. I will post a link to the app in the chat in a minute. And we'll head on. You can explore it yourself a bit. So this map shows the coloring of this map represents what we saw before, but in terms of ceiling classes. So representing the surface materials. And the redder they are, the more sealed the surface is. And the more green they are, the less sealed the surface is. So some of the surface materials have bigger cracks, and they still take part in the urban water balance of the city. But other parts of the built environment doesn't. And this allows us to see if we want to green the city and we want to increase the surface, for example, the surface area, then we have a bigger impact if we do it in a more redder area, for example. This could enable decision makers to make a decision, a proper decision. I go through this because I don't want to extend the time so much. There's a map on trees only, where you can discover the ages, the size of the crown. This, for example, is a Platanus, Acer Platanus, or this is a 40-year-old acorn tree, and it's got a crown diameter of 9 meters, but only a tree pit of 8.6 square meters. So massive trees have tiny spaces to root in. There's some diagrams to see about the species richness of the neighborhood, and also the number of trees per street, or the species richness of each street, and the ages when the trees were planted. This is all some interesting information. For example, if we want to make a decision on which tree deserves the first increase of a tree pit, for example, we need to know some information on the tree. And now the hard part, part of the app is the map on urban soils, and it looks like there's nothing on the map. but it represents the current status of urban soil and how it, the extent of urban open unsealed soil in my neighborhood, which is really tiny. And when you go closer, you see that it's basically only available in some tree pits and actually on some green roofs that are not represented right now, and in public spaces, in green spaces. And it's 7.2% of the total area. And here there's this interactive opportunity to now increase the sizes of, for example, the tree pits, to do some digital urban greening, let's say, and play a bit around with the fantasy. And at the same time, we can determine the amount of soil that's going to be needed to realize this measure. So if we say now we want to increase the tree pits, we want to double the size, we click on transform, then we see that around the sizes in the map, they increase a bit. And we see that 100 trucks would have to come into the city in order to fill up the holes that we get when we deseal the surface around the tree pits and fill up what's needed to fill up the root space, let's say. If we want to green some roofs, I'm a bit afraid that this is showing up. It's showing up. Yeah, if we want to say, okay, there's 71 houses already having a green roof in my neighborhood, we want this to be 250, for example, and then we have a slider here where we can say this is going to be an extensive green roof with a substrate depth of 10 centimeters. This can also calculate the amount of soil that we're going to need in order to establish it. And here we are already in a total of 150 or nearly 160 trucks coming in, carrying 30 tons of soil to bring it up. And if we want to increase the number of parklets that I showed you on the picture, which are a really nice community driver, as I experienced. So I didn't know my neighbors so well before, and I didn't know who's got which tools before. And now we really grew together, and there's a nice project that we share. And this stewardship, ecosystem service stewardship, is realized in this way here. But also this poses a big demand of soil, and here we can see the impact. One part of the tool that's not incorporated yet, so I can't show to you, is the soil demand from greened facades. Of course, the greened facades, they also need to root in soil, and they demand a certain amount of soil. There's another graph summarizing the increases and how the increases or how the greening measures that we choose here contribute to the increase of open space, unsealed surface. And if we do what I did, for example, now here we increase the tree pit we double the size. We establish some green roofs, and we put some more parklets, a lot more parklets actually. We reach a total surface of 11% of urban soils. Yes, and I will now post the link in the chat so you can take some time later to explore a little more and see what the neighborhood is made from. I hope the translation is not too difficult from the German. So this is the end of my presentation, and I'm really happy if you have some questions, remarks, inspiration.